Proxima Centauri is our closest star besides the sun. You know how far it is? It's about this much far away. It's 39.9 trillion kilometers. And if you look at the wavelength of gamma radiations, which, some of which we use in our PET scan, for example, its wavelength is very tiny. How small? It's this small. It's in the picometer range. So look, scientists have to work with very big and very tiny numbers, and it's very inconvenient to write them all out. So we needed a better system, and we came up with one, and that's what we call the scientific notation. And that's what we're going to talk about in this video. So what exactly is scientific notation? Well, it's a shorthand way of expressing these very large and very small numbers, all by leveraging the powers of 10. So first step is to understand what this powers of 10 even means. So a power of 10 basically means 10 raised to some number, which we call as an exponent. Okay, what does that mean? Well, let's see. Now the exponent can be a positive number or a negative number, so we'll explore both. Let's start with a positive exponent. It tells you how many zeros you need to put to the right of 1. For example, 10 to the power 0 means you have to put 0 zeros to the right of 1. You don't have to put any zeros to the right of 1, so it's just 1. 10 to the power 1 means you put 1 0 to the right of 1, so it's 10. 10 to the power 2 is you put 2 zeros to the right of 1, which means 100. 10 to the power 3 zeros to the right of 1 is 1,000, and so on and so forth. 10 to the power 6 is 6 zeros to the right of 1, which we call a million. And 10 to the power 9 would be 9 zeros to the right of 1, which we call a billion. 10 to the power 21 is 21 zeros to the right of 1. Does that make sense? But there's another interesting way to think about it. The exponent, you can think, it tells us how many times you have to shift this decimal. Okay, if it's a positive exponent, it tells you how many times you have to shift the decimal to the right. So if we have, say, 21 as the exponent, that means I have to shift this decimal to the right 21 times. So let's do that. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's what it is. That's how you can think about it. How many times you're shifting the decimal to the right. That's what a positive exponent tells us. So what do you think a negative exponent will tell us? A negative exponent will tell us how many times to shift the decimal to the left. And if you shift the decimal to the left, you get a number that's smaller than 1. So 10 to the power negative exponent represents a number that's smaller than 1. And now the exponent tells us how many times you have to shift the decimal to the left of 1. So for example, if I have 10 to the power minus 1, look, a negative exponent, it means I have to shift the decimal to the left once. So that is 0.1. If it's 10 to the power minus 2, I have to shift the decimal to the left twice. So it's once, twice. So 10 to the power minus 2 is 0.01. What is 10 to the power minus 3? Shift the decimal to the left thrice. So you get once, twice, thrice. You get 0.001, and so on and so forth. So for example, 10 to the power minus 6 would be shifting this decimal to the left 6 times. 1, 2, 3, 4, 5, 6. This is actually 1 millionth. 10 to the power minus 9 would be shifting this decimal to the left 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called 1 billionth. What is 10 to the power minus 17? Oh, a lot of fun. We have to shift the decimal to the left 17 times. Are you ready? Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that's how we can think about the powers of 10. The exponent tells us how many times you have to shift the decimal. If it's a positive exponent, you shift the decimal to the right because we need to get a big number. If it's a negative exponent, you shift the decimal to the left, making it a small number. And a small thing to notice is that even though the exponent is negative, the number is still positive. A negative exponent represents a number smaller than 1. A positive exponent represents a number bigger than 1. So for example, a terameter, which is a trillion meter, can be represented as 10 to the power 12. Or we can represent a microgram, which is 1 millionth of a gram, as 10 to the power minus 6. With this, we are now ready to understand the scientific notation. So what exactly is scientific notation? How do we write it down? Well, to express any number, we take a number between 1 and 10 and multiply it by the appropriate powers of 10. For example, To write 3 trillion, we just write as 3 times the appropriate power of 10 to get a trillion, which is 10 to the power 12. To write 2 millionth, we multiply 2 with the appropriate power of 10 for the millionth, which is to the power minus 6. So if we go back to our original example, we can write this big number as 3.99 into an appropriate power of 10, which is 10 to the power 13 kilometers. And by the way, we'll do some practice problems, so it'll make a lot of sense as to how to exactly arrive at this number. So don't worry as of now, let's just understand the concept. Similarly, if you had this, if you went back to this gamma radiation, which we had a very tiny number, you can again, in scientific notation, write this as 2.4 times 10 to the power an appropriate number. Notice it's a negative exponent because it's a number much smaller than 1. And so this is the scientific notation. And this number over here, we give a name to that number. It's called the significand. Okay, it ends with a D. It's also called the mantissa or the coefficient. All right. And so a scientific notation has a significand multiplied by a power of 10. Now, here's a quick question. Look at these values. Do you think this is written in the scientific notation? I want you to pause and think about it. All right. Well, at first it looks like that, but actually they're not. And the reason is the significand must be a number between 1 and 10. This is a number more than 10, so that's not right. This is a number less than 1. That's not right. The correct way to write over here is 1.86 into 10 to the power 8. And over here, it's 9.6 times 10 to the power minus 5. And don't worry, we'll do some practice now. But the big idea is that the significand has to be between 1 and 10. Okay, let's take some example problems. So here's our first question. An average raindrop contains 1.67 times 10 to the 21 water molecules. Express this value in the standard notation. Okay, so here's what's given to us in the scientific notation. So to express this in the standard notation, all I have to think about is the exponent tells me how many times I have to shift the decimal. Okay, now should I shift the decimal to the right or to the left? Well, it's a positive exponent. A positive exponent means I'm going to get a big number, right? And therefore I have to shift the decimal to the right to get the big number. That's how I can think about it. So let's do that. So we start with 1.67. Here's the decimal, and we're going to shift it to the right 21 times. So let's do that. Let's count it together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's the answer. This is how we express it in the standard notation. Let's try one more. The average diameter of a COVID virus is 9.5 times 10 to the power minus 8 meters. What is the value in the standard form? Why don't you pause and try this yourself first? All right, here's the scientific notation. The exponent tells me how many times I have to shift the decimal. Since it's a negative exponent, I know this number is going to be much smaller than 1. So I have to shift the decimal to the left. So this means I have to shift this decimal 8 times to the left. So let's start with what's given, the significand. That's 9.5. And then we just shift the decimal to the left 8 times. So let's do it together. 1, 2, 3, 4, 5, 6, 7, 8. Done. And of course, we're going to put a point. You're going to put a 0 over here. So this is the standard form. Okay, in the next question, we are given the standard form and we have to convert that into scientific notation. So read the question. It's a beautiful context. And try to do this yourself first. So pause and try yourself. All right. So we are given the standard in the standard form, the measurement in the standard form. This is 66 million grams. And now to convert it into scientific notation, the way I'm thinking is I just have to I have to get a number which is between 1 and 10. That's a significand. I have to get the significand which is between 1 and 10. So that's 6.6. So I have to get my decimal here. And currently my decimal is over here. So I just need to count how many times I have to shift the decimal here to get it to here, and then that represents the exponent. Okay, will it be a positive or negative exponent? Well, just think about it. This is a big number, so it's going to be a positive exponent. Okay, so let's count how many times you have to shift the decimal. So 1, 2, 3, 4, 5, 6, 7. So I've shifted the decimal 7 to get to 6.6. So that means my exponent is going to be 7. It's a positive 7 exponent, so it'll be 6.6 times 10 to the power 7 grams. That's it. Beautiful, isn't it? Okay, one last. Try it on your own again. Okay, so this is the standard form that's given to us. To express this in scientific notation, I need to get the significand between 1 and 10. And to do that, I have to shift the decimal to here so I can get 9.8. I just have to count how many times I have to shift the decimal because that becomes my exponent. So let's do that. So let's shift the decimal. 1, 2, 3, 4, 5, 6, 7, 8. So my exponent is going to be 8. Is it plus 8 or minus 8? Well, this is a very tiny number, so it's going to be minus 8. Does that make sense? So it's going to be 9.8 times 10 to the power minus 8 grams. That's it. All right, before we wind up, a couple of final things. Can we have scientific notation for negative numbers? And the answer is yes. See, you can write scientific notation for negative numbers. Everything remains the same, except now we have a negative sign. So this will be negative 178 million, and this would be negative 1.9 billionth. I mean, everything stays the same. You just put a negative sign. So yes, you can definitely use it for negative numbers as well. And the final question is, sometimes we'll have to perform big calculations with scientific notations. So how do you plug this into our calculators? Well, let's see. So for example, let's say we want to input this number into our calculators. How do we do that? Well, step 1, bring in a calculator. Then we input the significand or the mantissa. So 6.02, 6.02. Now how do we input times 10 to the 23? Well, it's just, there's one button called EE. Just press that. That represents times 10 to the power. And now you input the power. That's 23. I know it looks different, but that E basically represents multiplying by a power of 10. Also, in some calculators, you'll see a capital E instead of a lowercase e. It's the same thing. And that's it. This is how you do it. Now, you may be wondering, well, why can't we just do 6.02 times 10 to the power 23? For one, we have to do so many clicks over here, but more importantly, this can give us some serious errors when we're doing calculations, okay? Let me take an example. Let's say we want to carry out this calculation, this number divided by this number. The correct answer is 2 times 10 to the power 9. Let's see what happens if you do it the wrong way, all right? Let's just do that. So you get 8 times 10 to the power 18 divided by 4 times 10 to the power 9. Let's see what we get. Ho! You get 2 times 10 to the power 27. That's wrong because it messes up the whole division and multiplication. We'll have to put some brackets and all of that. Now we can avoid all of that mess. All we do is input it the right way. So 8 EE 18. So that's our first number divided by 4. Put this EE 9. This one. And look at what we get. Boom. 2 and 9 zeros. You can count that. And that's basically 2 times 10 to the power 9. And so this is how we input it into our calculator. So long story short, in scientific notation, we have the significand, which is also called the mantissa, which is a number between 1 and 10. It has to be a number between 1 and 10. It can't be like this. And that's multiplied by 10 to the power some exponent. Any number can be expressed as in the scientific notation form. And if you want to expand that out, then remember that the positive exponent represents a number much bigger than 1. So you just shift the decimal to the right that many times. And a negative exponent represents a number smaller than 1, which means you shift the decimal to the left that many times. And to input this in your calculators, just press the EE button.